Greetings everybody. J.J. Jenkins with the Construction Infection Control Training Institute here. Today we want to bring you a video showing you how to test filtration efficiency on your portable HEPA filtered air scrubbers. You may have the best HEPA filter in the world, but if it's not properly installed in this device, we can get what's called bypass around the filter. It's a lot easier for air to go around a filter in a system like this than it is for that air to go through the filter. And so what we have is rubber gasketing that ensures that seal of the front face of that filter. And in this case, this device, we've got a rubber gasket encircling the exhaust point here, and then the filter is a cylindrical filter that is pushed into that rubber gasket. So if there was any issues with that rubber gasket, dried, cracked, partially missing, then we would realize additional dust in that exhaust airstream because it was going around rather than through the filter. Okay, so what you're going to need to execute this testing of this device is what's called a laser particle counter. Okay, these are devices that measure dust concentrations at very small size ranges. And so when we have a calibrated laser particle counter, the rest is pretty simple. Okay, we're going to take 20-second samples today. Whether you take 20-second samples or 30-second samples, I think that's appropriate for testing of these devices. Long run samples, there could be variability in the room. Somebody could bump the device. It starts to get problematic when you run long-term samples when testing these devices. So 20 to 30-second samples is what I would recommend. So I'm going to power up the device. Let that fan motor assembly get up to full RPMs. Okay, you may be able to hear that in my microphone, I'm not sure. But now I'm going to take a reading perpendicular to airflow here. So I've started my sample. You'll notice how I'm holding the silver probe. It's perpendicular. The airflow is coming in this direction, but I've got my probe pointed in this direction. If I were to hold the device vertically, I'd be jamming the air into the probe. And if I held it upside down with the probe pointed at the device, I'd kind of be shadowing or shrouding the free airflow into the inlet, and that might not lead to the most accurate sample. So typically when we test air and flowing systems, it's perpendicular to the direction of airflow. Okay, so I've got, and I'm going to get close to the camera here and try to hold my hands steady so you can see this reading of 15,301. Let me get a little bit closer there. That's 15,301. That's my 100%. So 1% of that number is going to be 153.01. Okay? 153.01 is the 1% that I do not want to exceed here. Anything less than that value of 1% is even better, but that 1% is kind of my cut line on pass fail for this device. I know the filter is rated at 99.97% efficiency, but that's more in controlled environments. This is the real world. If I can demonstrate 99%, that tells me that the gasket is properly engaged, that the filter was properly installed and is doing its job. Okay, so let's put this to the test. Let's look for a value of 153 or less, because I had 15,301 going in. Let's see, I'm going to get over here on this side here, get close to the exhaust, trying to get the probe inside of that flange so I'm not entraining room air, holding it perpendicular to the airflow. I've got 12 seconds left on my sample and 7 seconds left on my sample, and 3, 2, 1. Okay, I believe if memory serves, it was 15,301 going in. So anything less than 153 is good. So now let me get close to this camera again, and hopefully you can see the numerical value of 4 in that top middle reading on the screen of the particle counter. 4. So out of 15,301 going in, I only have 4 coming out. That's well above 99% efficient. And in this case, this device passes. It's ready for prime time on your healthcare construction project. Now, we've collected that data. We want to retain that data on this specific device. So in a spreadsheet, I'm going to keep a log, but then I'm also going to put a sticker on this device. The type of information we want to save is the serial number of the device, the date tested, the name of the person that did the testing, the dust concentration that entered the system, the dust concentration that left the system, and then the percent difference between those numbers. And like I said, we're going to put a sticker on this device. We want to test these devices at least annually, or no more than, going a full year between testing, or any time that the HEPA filter is replaced. Not the pre-filters. In this device, we've got pre-filters up high. We don't need to retest when we change these filters. These filters are really just to lengthen the lifespan of that high dollar filter. That's really the only filter that matters in this system. This is more, these filters up front, with the exception of the carbon filter, are pretty much just for the owner of the device to save them money, so they don't have to change the high dollar filter down there in the bottom. So I hope this video was helpful. I'm starting to hear of a lot of hospitals that are asking their contractors or requiring their contractors to test their air scrubbers before bringing them on site. So maybe this video arms you with the functional intel to execute this strategy, so that when your hospital clients start asking you for this, you know how to answer that requirement. Hope this was helpful. As always, we welcome your questions, comments, observations here at SICTE. Have a great day, and good luck out there in the field.